Beautiful. All right. Can somebody out there in internet land wave if my sound is getting out? Can you hear me?
Your audio quality is perfect.
Okay, good. Perfect. All right. So today, gentlemen, we are going to do a trip down memory lane, looking backward and looking forward. We're going to be examining implications of Win32Forth. And so why the funny title? That's the starting point. The title, of course, is Exploring Win32Forth with Gun and Camera. How did gun and cameras get involved? Well, it turns out, as a child, I encountered books from the 1930s and 40s that used that format. Like one of them here was Whale Hunting with Gun and Camera. Another one was Along the Zambezi River with Gun and Camera. It was even adopted as a humorous book called Through the Alimentary Canal with Gun and Camera. Now, for the use in the biological field, you realize the alimentary canal is the digestive tract of the human body. So if somebody wrote a book about exploring the human body as if it was an adventure story around the world, and the memorable part was a stop with the island of Langerhans. So all of you diabetics out there know that the islands of Langerhans is in the pancreas, and that's where insulin is produced. So enough with the funny story. We're going to talk about Win32Forth. It is a fully featured Windows Forth featuring an integrated development environment, object-oriented programming, graphics. We'll talk about the features in a little bit, but it's a very rich platform. It runs on anything from XP up to Windows 10, and when you boot it up and run, you have 8 megabytes of free space to play with. That's your playground, is 8 megabytes of space. In it, there's 2,800 words of application words. This is the fourth core that comes up, and buried in the system are 2,600 words that are system words that are used to make the Forth itself run. It has also 20,000 Windows constants available. So if you're doing calls to Windows functions, 20,000 of them are predefined. It was written originally by Andrew McEwen in about 1995. He worked for me in the 80s and started the prototype of this. When work was a little slow at Dorado, he said, "Bill, could I do some side projects?" And we said, "Why, certainly." So he took our FIG Forth, updated it to Forth 83, then updated it to NC Forth, and then he left the company. He continued to work in development on his own for several years. He passed the work on to Tom Zimmer, who polished it. Bob Smith came along and helped him on the floating point. The project went back to Andrew, and then he released it in 1995, and it was for Windows XP. It's been updated several times since then by a European team with Anton Erdl and Joss Van and others. The last release was 2018. So here are the guidelines that Andrew set up for it. And, you know, I said, well, why and how did you do this? What was your thought process? So he said, by that time, 1995, quote, computers had plenty of memory. Well, now they've got gigabytes of memory. In those days, they had megabytes. But he said, because we have plenty of memory, I am not going to try to make this thing compact. I'm going to try to make it rich. So he included any word that he thought he might need, plus, of course, the internal development and a lot more. So there are words in here like to R. Well, normally you would write that to R, but he just wrote it as a single word. And then you'd have a word like R from and drop. He made that one word. And most of these were written in machine code. So anything that's what I call a small word, the fetch, store, drop, to, from, more than that are written in code. He figured he didn't care if the code was a little larger or a little bit smaller. Once he wrote it in code, he was done with it. He could forget about it. So he also hit a point where he was doing the graphics and the integrated development environment, and he needed really a richer graphics-oriented approach. So he then added object-oriented programming. He wanted, because he knew he was having so many words in here, he wanted to have a very fast compilation speed. So he does a hash dictionary search, and the dictionary is a 157-way search. So there are probably only a couple of hundred words in any search. Rather than searching 5,000 words, he's searching 100 or 200 words. I will load, no program I've written loads in longer than 0.2 of a second. The thing is blazingly fast. And I said, the little words are written in assembler. He is a very good client of Windows. He has a magic process to translate from a fourth virtual address into the physical address of your computer. And it's a short piece of code of 8 or 9 lines, whatever, in assembler, that is the magic that allows you to get inside of Windows. But he traps illegal memory accesses. So if you are accessing a prohibited part of Windows memory, it's trapped and it's brought you back to forth gracefully. So you don't, no blue screens, no crashes. You do abort and you come back and you're still in forth. So that is a lifesaver, because I tell you, I get outside the legal memory bounds all the time, and it brings me back again, and at least I can recover. So I wrote a book about this. Okay, why did I write this book? Well, from about 2000 on, I would come back to forth at irregular intervals. I would do a project or an idea or a presentation maybe once or twice a year. At that point, then, I would be forgetting some of the mechanics and some of the words and some of the techniques, and I had to kind of do a search then to find out. So I would learn these how-tos, and I thought to myself, I've got to capture this in writing, so when I come back to them, I can recover, and it will avoid my failing memory. So I started writing everything down. When I had to search something in the source code and read it, I would pull out the information and write it up. For example, here's why you need a book like this if you're going to use a rich language like Win32Forth. All of the words having to do with cells. You see the list there. There's cells, cells plus, cell minus, plus cells, minus cells. You're going to use one of those. Which one are you going to use? Well, if you have to go back to the source code to figure this out, you've got a problem. Now, there is a help system available, so you can do help on a single word, but you've got to know what the word is. And so if I do help on cell plus, I might be really looking at the wrong word. It should be cells plus. So by having it in paper, I have an index, like an index, takes me to the page. Bingo, I've got it. This forth also does disassemble words from memory. And if I type view and a word name, it will take me directly to the source code. So it's cross-indexed. Every word in memory is actually live indexed back to its source code. But you still need, somewhere along the way, you need some paper. So what do we have under the hood? What's there? Well, the first thing, it's a 32-bit forth. The integer values on stacks are all 4 byte 32 bits. There are double number and triple number support. So you can go doubles, and even there are a limited selection of triple numbers, 96-bit integer math. We have all the usual stack operators, math defining words. I'll skip over that. Everything you would expect, especially with NC Forth. There's a text editor, which is a file screen editor, but it is not interactive. With the editor, you just edit files and you save files, and that's it. But there is a graphics interactive development environment, which we'll show in a minute. Rich feature set, does floating point, strings, file access. You can do memory allocation for Windows, MLOT. So if you want another megabyte or so for a scratch area, you can pull it from Windows. And when you install the system, it automatically runs through a metacompiler, so it regenerates itself. So when you install the system, it has been freshly compiled, targeted for your computer installation. If you want to modify, you can go back to the source code and you can change the source code and then reinstall it, and it will come back with your changes. I have not had enough nerve to do that, and I've seen no need to do it. But if for some reason there was a little gap in the host system, I can always add a word or two. But I do not have the nerve to regenerate the system. It has separated heads between the headers and the dictionary entries, and I think there's a turnkey way where you can run the thing native forth on a turnkey basis. I haven't ever gotten into that. So here's some examinations. It's a very rich set. Here's numeric input. Live all the time. You can You can do inputs by signed integers, double integers, decimal numbers. You can force it to decimal even if you're in another base. You can do double numbers. You can do hex input, hex doubles, floating values, floating prefix, ASCII, so on. So most anything you want input is right at your fingertips. The memory operators are all you'd expect. They do cells, bytes, words, doubles, floats, and so on. So here's a quick summary of what you get beyond the basics. There is debug, which I used this for a couple years before I figured out how to use debug. If you put debug in a word name, whenever Forth encounters that word, it will single step it. You go through, and we'll show you a demo in a moment. So you single step, ding, 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 ding through that word, and it's done graphically. We'll talk about that. MLOT will let you pull memory from Windows. So not only can you use the dictionary to store information, but you can get dedicated memory space externally. And I believe with MLOT, it will auto allocate if you expand for more memory. I know when you bring a file in, if you bring a file in edit, you make a file declaration size, but then if you exceed that, Windows will automatically add more space so files can grow. You can create files, read, write. Words such as catch and throw are there, recursion, local variables, linked lists. Of course, the Forth Dictionary is a linked list, so there's a couple of words in there that handle linked lists. And then something called execution chains, which I just learned about. Execution chains, maybe other people are using, maybe it's a feature people develop, but this is the first I've heard of it. But execution chain is a way where you can do a linked list of Forth words, and you declare the Forth words in the linked list, link them together, and give it a name. And it's essentially, it's kind of like a colon definition, but instead of being at compile time, it's at runtime. So you can change that linked list at runtime. Typically, it's used for input parsing. So if you have some interesting choices on input parsing, you can construct a sequence of 1, 2, 3, 4 words that in sequence will do the parsing on that input. And it's, again, done at runtime. All full floats and transcendentals, all exponentials, all the trig functions, everything's there. It has user-definable error messages. All of the ANSI Forth messages are there, and they have a negative message numbers are ANSI Forth, and positive numbers are host Forth or resident Forth. It has multitasking built in. You can have direct access to DOS from the Forth interpreter. You can issue DOS commands. And so much more. I mean, it's and this Forth memory to machine is the thing I mentioned earlier, where it has this very nice interface that, of course, is invisible to the user, but it gets you from Forth memory to Windows memory. So that is the exploration along the full breadth and depth of what's in Forth and what's inside my book. Now, here's a couple of examples. This is the integrated development environment. So on the right, you see the window that shows your source code. You then can do all sorts of manipulation as you'd expect, reading, writing files, searches, you edit. There is a huge list of about 40 or so keyboard functions. So you can do control functions, control letters, shift letters, and you do every one I've ever, I use 3, I use select, exit, clear, insert, and that's all, but they've got about 50 or 60 of them there. On the left-hand side, you see the running Forth system. And so this, all you do is hit F12. F12 compiles what's on your display screen, starts the interpreter and runs the code, and you see the result on the right. You don't like it, change your source code, hit F12 again, recompiles, reruns. Just quick development, quick turnaround in, like I say, recompilation in a couple tenths of a second. Here's an example of a trace. A trace is beautiful. You say debug a word, and then when you execute that word, it will execute single step. So I have a word on the right called by word. It's 3 do loops. One do loop talks about green, gold, and none. So on the left, that is executed through the green portion. So you see all the do green, do green, do green. Now we got down to the I's. On the bottom left, the code word I is circled. And on the top right, there's a red circle around the I in the source code. And you notice how it's on a white line and it's highlighted in gray. So that is the next word to execute. So when I hit the space bar, that word will execute, and I will see then the results on the parameter stack. This can be single step, it can be auto compute, complete. I don't know, there's about 12 different single step functions that are available. I have a little cheat sheet on them. I don't remember, I have to look them up. So here are the comments in summary. The only bug I found in the system currently is the go-to-xy. The first time you run it, it will plot in some random position. It needs to be initialized. So whenever you use go-to-xy, the very, very first use, you just plot somewhere, say, 0, 0, go-to-xy. Now it's initialized. From then on, it works. That's the only hiccup. It's written in machine code, and so I'm not going to maintain it. The object-oriented programming is a major component of this, and Andrew has written a 12-page introduction to it, but it just skims across the top of here's what object-oriented programming is all about. It's not a how-to guide. It doesn't really get you into how he's used it, but it's a good introduction, and that's about it. There is limited output floating point. Basically, they have F number, and that's it. Or F dot, I guess it is, F dot. And it does variable, you can specify the decimal places, and that's it. But if you want to vary the decimal points, you have to go keep changing precision and so on. So if you really wanted to do advanced formatting with floating point, I think what you have to do is you'd have to break the integer and fraction parts into separate integer words and then use Forth's pictured output. If you're going to do commas, European commas instead of decimal points, if you're going to do dollar signs and so on, you've got to kind of go write that yourself. And I looked at the floating point formatting, and it's formidable. A floating point formatting output is maybe 30 lines of code, and it's pretty dense. So other than the limited floating point output, I think everything else flows beautifully. So here's why I'm stuck on Win32Forth. The structure and capability is unchanged for 25 years. The design concept is frozen since 1995. So it's a stable platform, ultra stable platform. And the only changes that have been made to it have been to keep it up to date with changes of Windows. It's all I need, and it's more than I need, like all of object-oriented I haven't gotten into. So there's a lot more into it than I even need and use. So it solves my needs for writing applications. If you're trying to do some kind of advanced research, if you're trying to do machine control, you've got to get into it and wade through how do you talk to ports and so on. But anyway, I bet it's in there somewhere. So the book I wrote currently is about 100 pages. It's a PDF. It's available on GitHub at Bill Ragsdale. Nothing secret about that. Just go there and download it. Currently, it's release number 22. And about every 6 months or so, I made enough changes in it to do another release. So that is it. Let's see if I can get out of this. There we go. And do we have any questions briefly? Because I have a hard time hearing questions anyway. Good, thank you.
Okay, it says conference brochure. Did you stop screen sharing, Bill? All right, I don't know why, but the camera isn't focusing on me. Is it focusing on me over there?
It is.
All right, I feel like we've accomplished something. Maybe it's because I'm me, so it's not focusing on me on my screen. Go figure. Now, as is our tradition, although this year without the log fire in the introduction, we present the annual fireside chat. Chuck?
I'm here. Can you hear me?
We can hear you just fine.
A little higher with the volume.
You need to move closer to the speaker. Sorry. All right. I'm going to mute myself.
Do you see a screen?
We do not.
Okay, UHD4th.
You may need to reshare your screen. I think I grabbed it away from you when we presented. There it goes.